Now in the middle of one of the most significant eras in automotive, Carl Anthony amplifies the minds and voices behind this historic transformation as the host of AutoVision News Radio.
Mic check 1, 2.
All while coming to terms with middle age, father loss, and what it means to be successful in Detroit.
In the mid-1990s, our school organized an event with local law enforcement and Operation Lifesaver, a nonprofit that provides free public education and awareness programs to prevent collisions, injuries, and fatalities on and around railroad tracks and highway rail crossings. At the event, held about a year before I received my Iowa learner's permit, we were given a circular yellow keychain that resembled a railroad crossing sign. On the back, it read, "Look, listen, live." About 8 miles south on U.S. Highway 75 from Lamar's, where I grew up, is the community of Merrill, named for Samuel Merrill, the 7th governor of the Hawkeye State. As you head south through Merrill, say if you were to continue on 75 to Sioux City, you arrive at a set of train tracks that everyone, parents, teachers, local police officers, everyone urged you to be extra careful when approaching. Even though there were pavement markings, road signs, cantilever flashing lights, and crossing gates. The train tracks in Merrill slice across Highway 75 at a somewhat unconventional angle or skew. Depending on which direction the train is coming from, it may be hard to see from a distance against the rural Plymouth County backdrop, even with its lights on. Or it may be obstructed by houses or local businesses as it travels through the backside of Merrill on the way to the Highway 75 crossing. When I drive through Merrill again all these years later, when I return home to Iowa for holiday visits, I do what many in our industry do. I look at that immediate landscape through a set of ADAS lenses, observing the cars, the road, and the railway crossing. As they taught us during that Operation Lifesaver event in the 1990s, if a car and a train meet on the tracks, it's not a tie. In a complex driving environment, is there a way to alert drivers ahead of time through the vehicle's instrument cluster that a train is present? Could the interior DMS camera leverage that information to warn a distracted driver so they don't risk a collision with a train? While it's standard procedure for school buses to stop at railroad crossings, could an ADAS innovation still let the bus driver know in advance that a train was coming? How helpful might such a feature be for the high school basketball team returning late on a Friday night after a big game? Could DMS features on board a school bus provide fatigue alerts to prevent a close call with a train? In other words, how can we leverage the latest innovations to reduce cognitive load in demanding driving environments so that everyone gets home safely? This is the core question at Seeing Machines. How do we get everyone home safely, whether in a passenger car, fleet vehicle, mining application, or aircraft? Launched in 2000 at the Australian National University in conjunction with Volvo Technological Development, the founders of Seeing Machines held fast to a belief in those early days that a driver monitoring system fueled by the science of human factors was foundational to a crash-proof vehicle. Paul McGlone, Chief Executive Officer of Seeing Machines, leads the company today as it carries forth its mission to get everyone home safely. He has extensive experience in logistics and supply chain management, having worked closely with the automotive, rail, and aviation industries throughout his career. Paul holds a Master of Business Administration from the University of New England and a Master in Applied Business Research from the Macquarie Graduate School of Management. The first use case for Seeing Machines and its technology was in the mining industry, eventually branching into trucks, buses, aviation, and other automotive-grade applications. As we begin with Paul, he speaks about the company's relationship with Caterpillar and how it has served as a baseline for what Seeing Machines is doing today.
Moving at the speed of mobility, this is AutoVision News Radio with Carl Anthony in Detroit, Michigan.
And Caterpillar today uses our technology exclusively in the mining vertical. If you think about the rationale for that for Caterpillar, you've got a $5 million piece of equipment driving around a mine site, and often the drivers of these equipment are doing 12-hour shifts, 7 days a week, 7 days on, 7 days off. They have fatigue events like all humans do. But when an event occurs that results in an accident, the economic circumstances, even if no one is injured, is profound. The machine stops, the mine shop stops, the output stops. That was really the rationale for Caterpillar to the mine operators for use of this system.
Sure.
And then from that, we built out from mining trucks into essentially a heavy fleet, road transport. Today, we have more than 60,000 trucks connected. We develop, contract manufacture, and install a hardware system that sits on the cabin of a truck, and it detects fatigue and distraction in drivers. It connects through the cloud 24/7, alerts the driver's supervisor in a closed-loop fashion to keep them safe. And so that's a really important part of our business. It's where we started, but it also enables us to collect a vast quantum of naturalistic driving data. And that is really central, amongst other data that we use, to develop high-performing algorithms that we deploy into automotive.
Yeah.
So that leads us to the automotive sector, where we put our tech into new vehicles. And the way that business operates is quite different to fleet. In fleet, we sell hardware and we sell services. Those services connect the truck 24/7. In automotive, we're essentially selling software through a tier one into an OEM, a manufacturer. Whilst we sell the software, we're heavily involved in system design, and that means what's the optimum optical path? What is the way that we can compress our software to operate on the smallest silicon component? How do all of those elements come together to deliver a safety solution that performs its job without annoying the hell out of the user or the driver?
Sure. Paul, let's expand on this further, because seeing machines is also present in aviation to support the work of pilots, air traffic controllers, and other personnel. Two-part question here. First, tell us about the work that you're doing in aviation, and then further to that, what are some key learnings from aviation that you have been able to apply to automotive?
The aviation supply chain or value chain is very similar to automotive in that you have OEMs and tier ones and regulators. And if you replace the cars with planes, it looks exactly the same. The big differences are timescale. An aircraft production run life is 20 to 30 years, and a car is 5 to 6 years. The rate of technological change or upgrade in aviation is actually very slow, but big and profound. Now, in a post-COVID world, air travel is ramping. There aren't enough pilots. There are more stresses placed on pilots and airline operators. Fatigue and cognitive overload are very significant issues that manifest into risks for airlines and the traveling consumer.
Right.
In that space, we put our technology into training simulators, an exact duplicate of an aircraft cockpit where they train pilots. So we, for the first time, have enabled monitoring system that essentially tracks very accurately the position of the eye gaze, among other things, so that they can quantify the training outcome. In the past, a pilot was in a simulator, there was a trainer behind them, essentially with a noteboard, and saying, you're doing well or otherwise. And now, with very accurate eye gaze, it can be precise. Are you looking at the place you should be to execute the routine that has been asked of you? Now, if you move through that chain into aircraft, so you can now connect the training outcome with the actual flying outcome. But in addition to that, you can be monitoring the pilots as they experience these extreme events, whether they be stress events, overload events, fatigue events, because, of course, that risk is profound. I think some of the key learnings are, because automotive has fantastic requirements for performance, aviation are just that level above in terms of additional requirements for performance. Sure. And that leads into the regulations, how you can get new technology approved in an aircraft, in a training environment, in an air traffic control environment. It's next level complicated. There needs to be complete traceability right back into the design of the algorithms, which is why we elected to partner with Collins Aerospace. And they do all of the heavy lifting in terms of that regulatory if I'm fair, above our pay grade.
Sure. And underpinning all of this, fleet, automotive, aviation, is your emphasis on human factors. Why is human factors such a critical aspect of this, Paul?
This has been our belief, driven by the founders of our business long before I arrived here. And it's proven to be a very important sort of bedrock in the design of our software and systems. The difference between a good ADAS system and a less good ADAS system is fundamentally in the human-machine interface and how that design comes to life. This is where the human factors scientists earn their money, and they earn it certainly in the domain of research and how that research is applied to our product development, but it's earned fundamentally in designing systems that perform the task they're meant to perform without annoying the user, because when you annoy the user, it discounts the validity of the feature. Because you turn it off, you put a piece of sticky tape over it, you forget that it's important.
Right. Quoting Paul from the Seeing Machines website, OEMs are faced with a maze of electronics, software, and sensor integration options for interior monitoring systems. Coupled with market dynamics, which are now driving rapid adoption and mass market penetration, the Seeing Machines embedded product strategy has been designed to support a wide range of common integration, cost, and safety performance challenges with the flexibility to support the unexpected. Can we talk more about it? What is the Seeing Machines embedded product strategy, and how does it lead to safer vehicles?
Just hearing that read back to me it causes me to think, but it's actually a good example of the level of complexity that we're seeing emerge in vehicles. So we're talking today about the software-defined vehicle. We're talking today about vehicles that are becoming more intelligent, vehicles that are integrating the external environment with the internal cabin environment and enabling the operator or the driver to take actions or have experiences that are safer and certainly more pleasant. Now, all of that happens through an array of sensors, software, and features delivered through messages that all combine and have to integrate and work together in a harmonious way. And if you just step back from that for a second and say, wow, how on earth can that happen?
Yeah.
So when we talk about embedding, we're really talking about taking what is the vision software that we develop is actually what we would call sort of processing heavy. Unattended, it requires a fair bit of space on a silicon device to process. We have deep expertise and know-how, our kind of secret sauce, if you will, that enables us to compress that whole software stack into a 10th or a 20th of what it would otherwise be. We then embed or pre-install or collaborate with the SoC vendors to design the tools, the products that enable this software to happen in a very, very efficient and economical fashion. That is, they use less processing space, less processing power, but still deliver the high performance that is required. So that's a deep specialization. Now, one of the interesting things here is that we only sell software, but the know-how that goes into this particular area of driver and occupant monitoring, it's very narrow in terms of what it does, but it's very deep in terms of the technical requirements to make it work in a commercial world. This embedding approach that we talk about, similar to our systems approach, is all the effort that we go to sell software that performs. And that's what we think makes a difference in the way we do things.
Late December 2024, you announced a collaboration with Mitsubishi Electric Mobility Corporation to pursue joint growth opportunities around DMS and OMS. How did it all come together? How did this collaboration come together with Mitsubishi Electric Mobility Corporation? And what are some of the highlights of the partnership?
So glad you've asked, because this is quite fascinating and it brings together many facets of essentially what's happening in the space worldwide. The Japanese market is a really interesting subset of that. We've been dealing with Mitsubishi Electric Mobility Company for 5-6 years.
Okay.
And so it's a very long-term relationship. Just perhaps a year ago, we've started working on a specific, what we call RFQ request for a certain car manufacturer. And as we were working with them on that and building a closer relationship based on our joint capabilities, we got to know each other a lot better.
Yeah.
And then if you step back from that and you look at the automotive market more broadly, you've got all this change happening. Mitsubishi Electric Mobility were for many, many decades in the automotive hardware space and offering third-party software. The changes that have been brought to bear in the auto market broadly and in Japan also, essentially a move from hardware to software-defined vehicles, that brings a lot of pressures into these tier one companies. This particular tier one, Mitsubishi Electric Mobility, had the foresight to recognize this change, what it meant for existing long-term tier one suppliers into OEMs in Japan, and developed a strategy to move with the market. So I think certainly in terms of the Japanese market, they're a first mover in changing strategic direction to become more software orientated. And in order to do that, they went through a competitive process whilst working with us and selected us as the collaboration partner for software for the interior of vehicles. And they have a much bigger software-defined vehicle program and strategy, and we have been identified as a very important component of that. And we agreed that a more formal collaboration would be jointly beneficial. And so as a consequence of that, they made the investment in December, and we are now pursuing opportunities together in the automotive space in Japan. But we're also looking at two additional areas, and this is what made Mitsubishi Electric Mobility unique to us. They have a very large aftermarket business where they sell electronic components to trucks worldwide. Because of that channel that they run, we both came to the conclusion that that would be a wonderful channel for our fleet or aftermarket product. To put that into perspective, Mitsubishi Electric Mobility US aftermarket channel that sells distributors and those sorts of things into truck fleets, they have customers that run approximately 1 million trucks in the US.
Wow.
So
yeah, it's incredible.
We both sat back and said, this is an amazing untapped opportunity for both of us to help them transform their business into a more safety-orientated channel and to help us distribute our core product.
Indeed.
And then from there, who knows, back into Japan, perhaps Europe, but US is the focus for that. And then the third area, as we look at Mitsubishi Electric, of which Mitsubishi Electric Mobility is a wholly owned subsidiary, and we look at all of the other vertical markets that they're in. I mean, they make everything from air conditioners to satellites. There is real opportunity in the adjacent markets where they have a leadership position for vision systems. And so we'll be pursuing that without getting distracted from our core focus of transport. This is going to give our investors optionality into the future that is really important. But also, when we look at adjacent market opportunities, leveraging our core tech, we learn from all of those. And then we bring that learnings back into the core and everyone benefits.
All of this that we've been discussing, from fleet to automotive to aviation to your latest news with Mitsubishi Electric Mobility Corporation, when we take all of that together and we look at the landscape, what are some of the most important trends that you see right now with regard to ADAS and DMS and OMS?
One way that I like to think of this is that we currently have an array of technology in vehicles, and if we combine all of those elements that you've just mentioned, we now have a vehicle today with lots of technology, lots of sensors, lots of fusion, lots of integration that can react in real time to minimize harm. In addition, it can provide an environment that has a wider array of features that make the driving experience more pleasant, whether that be color, sound, interaction with a head-up display, using gestures, using eye position to control the features within the vehicle. All of these things enhance the user experience, but they're delivered through this core requirement to have a safety system that needs a camera. So we have cars today that can react very quickly to minimize harm. In the future, and I would say the not too distant future, we're going to have vehicles that manage this portfolio of technology, being software, sensing, communications, in an integrated fashion. And that will enable the vehicle to anticipate as opposed to react. So if you think about the systems today, in an instant being able to react by tightening a seatbelt or slowing the vehicle, pulling the vehicle over, depending on the perception map of the exterior, all that's really important, keeping you in lane, that's all reacting to your environment. In the future, we believe vehicles will be anticipating the environment, anticipating the risks, and alerting the driver to take a course of action that will avoid the event. And so we're really moving from minimization to avoidance. We're moving from reaction to anticipation.
Right.
So I believe that the cabin monitoring technology, the environment that we specialize in, will become one of the most important safety mechanisms in the vehicle. It'll be required to understand the precise physical dimensions of the driver, the occupant, and whatever else is in the vehicle. And this mapping, this 3D enablement of that cabin vision to provide a perception map that enables a whole range of features to be deployed with extreme accuracy so that they can be relied upon for safety, like redirecting the trajectory of the airbag, for example.
Sure.
It'd be really great if the car knew that you were a tall person or a short person, a thin person or a wide person, and act accordingly. Understanding the cabin in real terms and having that interact with what the car's seeing externally and having a fusion of all of this information will present opportunities for car makers to make cars that anticipate and avoid. And that's where I think it's going.
With that in mind, anticipating and avoiding and the proactive, I'm going to again read something back to you from the Seeing Machines website. Seeing Machines is on a mission to achieve zero transport fatalities, which is one of the best visions any automotive, and let's add fleet and aviation, but it's one of the best visions that any organization can have. Paul, what is the driving force behind this mission for Seeing Machines, and why have you and your team placed this as first and foremost?
Ensuring that everyone gets home safely is our purpose and central to what we do as a company. It came about because in the very early days, as I said, when our founders were looking at vision tech and trying to apply it to a whole range of worldly problems, they got drawn to this whole issue of 1.3 million at the time road deaths, of which the majority are caused by fatigue and distraction. And if you take that 1.3 million, multiply it by a number that's either a financial number or an impact on the human domain, that you just put lots of zeros on the end of that. So this is just a massive, epic human financial impost on everything that we do and everyone that we know. Our founders came up with a technology and a set of science that could convince the regulators, firstly in Europe, that there was a technical solution that could impact this profoundly terrible outcome. And so it's central to what we do today. Safety AI, if you will, safety technology is central to what we do. Now, we do understand that we have to develop convenience and comfort features as well, because that's what sells cars. But at our core, it's about safety. And getting everyone home safely is something that anyone in our business, if you ask anyone in our business, tell us about your purpose, that's what they'll say. It's what drives us and holds us together as a team. And I often say something really silly, like since machine learning and AI became very popular acronyms, you can apply machine learning and AI to speed up the opening of an envelope, and you could probably make $1 by doing it. But who cares? What we do, we care about. And for us, that's important.
Links in the show notes for more information about Seeing Machines, software-defined vehicles, Operation Lifesaver, and the railway crossing in Merrill, Iowa. AutoVision News Radio is available on the digital antennas of Spotify, Apple Podcast, Podbean, and more. In Detroit, alongside Paul McGlone, I'm Carl Anthony, AutoVision News Radio.